Okay, hi, I'm Dr. Hsuan Chen. Welcome to another episode of me talking to myself. Today we're going to talk about creating translucency, especially in CAD/CAM restorations. I've given lectures about interior aesthetics in many different countries, and it's always interesting that wherever I went, somebody will ask me this question. How do you make your restorations look so translucent? This is usually after they learn that I tend to use many low translucency or LT ceramics in my clinical cases. Case in point, here are 3 different patients, all with 4 ceramic restorations in the interior region. It's a good demonstration of the range of translucency from looking opaque at the top to being quite translucent at the bottom. And yet, all of them are actually the exact same ceramic. In my last video, I also showed a case for a fairly challenging situation, which is a single unit lateral incisor treated in 1 visit. And people like to ask about the techniques to achieve this, which is reasonable, but to me, there is a fundamental problem that I think is much more important and interesting to answer, and that is, what exactly makes something look translucent? When dealing with ceramic restorations, there are basically 2 types of translucency. The first type is the natural translucency of the ceramic, or its intrinsic property. Here on the right is a CAD/CAM ceramic restoration that was milled and then immediately fired without any post-processing. It has some translucent characteristics, but it's uniformly translucent, and for the most part, our natural teeth aren't like this. So we can enhance the translucency in some parts and then reduce it in others, like this one on the left. Now, when I say to enhance and reduce translucency, that is in fact impossible, because the ceramic structure did not change really in any way. Technically, we are creating an illusion of translucency with extrinsic changes. And there are 2 ways to do this: color gradient and specular light. So how does it work? One of my hobbies is to create 3D models. And when I have extra time, the challenge is always to create renders that look as realistic as possible. Whether it's for acrylic material like for this root and surgical guide, or a titanium metal like for this implant guide, there are always some level of translucency involved. And so today I want to use this kind of a simulation as a tool to explore how this works. Here I've set up a simple scene in Blender. We have a crown, a sphere, and my initials H and C. So let's give it some proper lighting and see how it renders. Okay, we can see this material that we're using is completely opaque. What can we do to make it appear more translucent? Well, the first thing we can do is to add a color gradient. When we perceive something that looks translucent on the computer screen, like you are now, there's really nothing translucent about it. It's all just colors projected from the screen into your eyes. In this example, this translucent area is just a shade of gray. And by juxtaposing various shades of gray, we can create an illusion of light and shadow. Therefore, we can think of translucency as simply a gradient of colors. Now let's see what happens when we try adding some colors to our models here, like this. Most people would agree that it does appear a little bit more translucent, but something isn't quite right. The reason is that the surfaces are appearing too flat, and that's because visually, there are not enough clues that tells us the contours and the shape of the crown and the sphere. In the 19th century, there was a Russian painter named Ivan Aivazovsky, and he was considered to be one of the masters of creating translucency in his artwork. With just paint, he was able to create these vivid and glowing bodies of translucent water. And if you look closely, you'll see that it's more than just color gradient. He adds highlights to give form and layers to the waves, and that's what sells the effect. In dental restorations, even for really opaque provisional materials like this, if we see more specular highlights on our restoration, it helps us to visualize the 3D contours and create an illusion of depth. So if we add a little highlight to our render here, now it looks a little bit better. The color fallout at the incisal edges give the impression that it is more translucent than the rest of the crown, and the highlights suggest shape and depth. If you want, you can go further and add a dentin layer to make it even more see-through. But remember, you're not seeing through anything. It's just colors and highlights. And clinically, these 2 effects are added via staining, which gives the color gradient, and controlled glazing, which gives the highlights. The proper application of these 2 techniques can give you a very realistic looking restoration that will fool most dentists. Any depths or layers or subsurface characteristics that you see here on this veneer are all carefully constructed illusions. And coincidentally, this was a live demo patient with a live audience of dentists. And so it's not enough just to have pretty pictures. We needed to fool dentists up close. And now maybe some of you can start to see the two elements at work here. So we've talked about the extrinsic translucency, and you might be wondering, what about the actual translucency of the ceramic? When does that come into play? In our previous example, there isn't actually anything really translucent because we simply added colors and surface reflections. Now, through the power of computer magic, I can tell it to let the light pass through, and let's see what happens. We end up with something like this. One thing you'll notice straight away is that when translucency goes up, the crown looks darker. This is an exaggerated example, but it illustrates the biggest challenge when you rely on the actual translucency of ceramics. It is difficult to increase the brightness of a very translucent ceramic, especially if your ceramic is thick, and so you need to choose your material very carefully. And if your ceramic is thin, then it will be easily affected by the color of the tooth underneath. Of course, in real clinical cases, it won't be this extreme, but our eyes are surprisingly sensitive when the brightness of two things don't match. And if your restoration is too dark because of its intrinsic translucency, there's very little that you can do to salvage this. Remember that for one-visit chairside restorations, we don't have the luxury of cutback and layering. And so usually the best thing to do is to choose another ceramic with lower translucency and then apply extrinsic changes. Does that mean ceramics with higher translucencies are not as useful? Well, here is a patient with naturally translucent teeth, and it will take a considerable amount of staining, glazing, and firing to make a low translucency ceramic look like this. Sometimes it's simply impossible. As I begin my preparation, if I already know that I'll be using a high translucency ceramic, then I can adjust my preparation design to match the thickness needed by the ceramic and get realistic results without too much staining and glazing. But whether the ceramic has high or low translucency, for interior restorations, you almost always need to have both extrinsic and intrinsic translucencies working in tandem to achieve aesthetic results. In essence, it's a color gradient and some highlights, staining and glazing. So the next time you see a one-visit CAD/CAM case like this one I posted a month ago, see if you can spot the extrinsic changes that Sally here has made. It's something that once you start to notice, you can't really unsee it anymore, but even if it loses a little bit of the magic, I think we can all end up appreciating the aesthetics even more. These concepts are a little bit harder to distill into a short video, but hopefully you were able to learn something. Let me know if you enjoyed it. I'm Dr. Hsuan Chen. Thank you for listening, and stay safe.